Hi everyone, welcome to the fifth lesson for topic 3.3 Graphs and Networks. So for today's lesson, we are still under the subtopic of paths and cycle, which will be looking at how to solve practical problems to determine the shortest path between two vertices in a weighted graph. Alright, so this is one of the application of graph. So I just want you to remember that after today's lesson, you should be able to know how to find shortest path between two vertices in the network that is given. Alright, so let's start with the lesson. Alright, let's start with a very quick recap on what is that meant by weighted graph that we have covered in our first lesson. Okay, so a weighted graph is a graph in which each edge is labeled with a number that used to represent some quantities associated with the edge. Okay, so quantities. Okay, so for example, when you try to look at your handout, your first page of your handout, so this is an example of the weighted graph. So you can see that there's number on each of the edge, and all this number actually represent a certain quantity. Okay, so this quantity can be different thing. So for example, it can be a representative of what is the distance between the two towns. So if let's say the vertices of the graph means towns, so which means that when you try to look at the number on the edges between two vertices, that means the distance. Or it can also means that what is the time that require for you to travel from one town to another. So even you can try to talk about the cost that you need to spend if you want to travel between the town. Okay, so all these quantities are possible depends on the situation that given in your question. Alright, so for today's lesson, we are going to look at shortest path. Okay, so what is the shortest path problem? So it is a problem of finding a path between two vertices in a graph such that the sum of the weight of the corresponding edges is minimized. Okay, so just now we mentioned that the weight on each of the edges can represent different quantities, right? So based on the question, the shortest path that we identify, it can be either the shortest distance that you need for you to travel from one vertex to another vertex, or it can be the shortest time that you need to travel from the where you depart to where you want to reach, and then it can be also the lowest cost that you want to spend. So depends on the situation that given in the question. Okay, so there are three ways that we can try to identify the shortest path of a problem. So how can we do that? If let's say you are given a very simple networks, right? So for example, like this. So what we can try to do is we can identify the shortest path by using inspection. So in fact, inspection meaning by observation, you look at the network that is given, then you try to use some mental calculation, then you should be able to get it. Or the other way that we can try to do that is we try to list out all the possible routes. So by listing out all the possible routes, then we try to find out which one is the shortest path. Okay, so this is an example of a very simple weighted graph here. So we will try to take it as this is like the distance when you want to travel from A to B. So this is a distance where you need to travel to A from C. Okay, so now the question wants us to find the shortest path from A to D. So meaning that which is a way that can help me to minimize the distance that I'll need to take so that I can reach D from A. So that's our objective. Okay, so by looking at inspection, right, then you can just imagine, so 12, 17, so you can imagine this route will give you 29. Then after that, the other way that you can try to think is, 12, 6, 10, then you are able to get 28. So the 20, 10, then you are able to get 30. And then 36, then that's just 36. Huh? So meaning the shortest distance that you can take is basically 12, 6, and 10. So this is what is that called by an inspection. So which means that you are just looking at the path, then by using some mental calculation, then you should be able to get it. But so the other way that you can try to do that is listing all the possible routes. So for example, we can see that if let's say you want to reach D from A, then what is the possible routes that you can take? For example, if let's say I go from, this is a bit similar to inspection, but then you are just listing out everything in a written way. So if you want to go from A to B and then to D, then which means that you are going to take like a distance of 29. Okay, so the other possible way is like A, B, C, D. Am I right? So that's why A, B, C, D. So that's why you have 12 plus 6 plus 10. So which means you are able to get 28. So the other possible one may be ACD. So which means ACD, then you are able to get 30. Then after that, the last one, you straight away reach D from A. So that's why AD, you need a distance of 36. So by looking at all the distance that you have from all the possible routes, oh, sorry, I missed out one. So the other one, it can be ACBD as well, right? So ACBD, because this is not a directed graph. So this is a two-way thing. So you can go from B to C at the same time, you can go from C to B as well. So ACBD is an option also. So for ACBD, then you will need 20 plus 6, so 26 plus 17, so you are able to get 43. So that's basically all the possible routes that you have. So by looking at all the distance, then you can identify the shortest one, which is going to be ABCD. So which is going to give you a distance of 28. Okay, so this is an example of a very simple one. So you can just by looking at it by using inspection or listing all the routes. So something that I want to emphasize here is that finding the shortest path does not mean the shortest length of walk. So for example, you can see that for you to reach D, if you want to find the shortest length of walk, right, then definitely this is the shortest one, because by using the length of walk of 1, then you can straight away reach D already. But then you didn't pass through other vertices doesn't mean that it gives you the shortest road. Okay, so that's the idea. For example, if let's say when we try to talk about, we have highway here, right? So maybe you want to, this is your where you want to depart, and this is where you end. So you have different route that can help you to reach this destination. So for example, if I choose this highway, then maybe I only need to pass through like one toll here. Okay, if I choose to pass through another road here, then maybe I'll need to pass through two toll. But it doesn't, by looking at my picture here, then obviously, okay, let me try to draw like this. So maybe I try to draw like this. Okay, so for this road, I only need to pass through one toll. Okay, so the idea is, if let's say I want to find out the shortest distance, I won't be looking at how many tolls I will need to pass through, right? I'm going to look at what is the distance between every toll, and then I try to find out the total distance. So that's the idea. So by having the least length of walk doesn't mean that you have the shortest path. So for example, you can see ABCD. So this road is actually having a length of walk of 3. So which is like the maximum that you can see when you try to compare to other which has only 1 and only 2. But in this case, you see that it gives you the minimum distance. So that's why this is the shortest path that you want to take. Okay, so please remember that shortest path is not the same with the shortest length of walk. So make sure that you understand the idea. Okay, so this is an example of a very simple network, but in most of the cases, right, we will have much more complicated network. So when you try to look at your example one, you will be able to see that when you try to look at this diagram, right, this network, you can try to imagine if you are going to do inspection, it's kind of hard because there's like too many things happen at the same time where you need to check one by one. If you want to use listing, then also you can imagine you can go through A, B, E, H, A, D, E, H, A, D, E, G, H, A, B, E, D, G, H as well. So you have like much more when you try to look at the bottom part. So you can imagine like there will be a very long list if you are going to use inspection or you are going to use listing of all the possible routes. So that's why listing everything might be quite tedious. If we want to do that, it will use a lot of energy and time as well. So that's why for a much more complicated network, we will try to use an algorithm to help us to solve the problem. So what is that meant by algorithm? Is basically a method of solving a problems by repeating a sequence of steps. So later when I try to show you two examples, right, then you will see that the questions that I try to ask, the steps that I try to guide you is always the same for every step. Then you are just going to repeat the steps until you get your last answer, which is the shortest path that we need. Alright, so in the example below, I'm going to guide you step by step by using the network that's given, for example 1 and 2. Then after that 3 and 4, we are going to do everything in one single diagram, which is the normal situation that you will have when you try to attempt the question in your exercise. Alright, so now let's try to look at example 1. Alright, so I'm going to show you the algorithm by using this example. So make sure that you really have your hard copy or soft copy when you try to follow through the video, because if not, you are going to lose very soon if you didn't follow me throughout the process. Okay? Alright, so example 1, determine the shortest path from A to H in the network shown below. So this is the networks that's given. So you need to depart from A and you reach H. So in this case, we try to assume that the numbers, the quantities that represented by all the weights here is the distance. Okay, so later, for example 2, 3, 4, then you are having a proper question there. So this is just an example so that I can explain how algorithm works. Okay, so now step 1, what do we need to do is to find the shortest path from vertex A to H. We will start with A. So that's why this is where I try to look at now. Okay, so the next question that I'll ask myself is what are the neighbors of A? So which means that what are the few vertices that is adjacent to A? So in this case, you can see that the vertex that is directly connected to A are B, D, and also C. Am I right? So let's try to write down here B, D, and also C. Okay, so what do we need to do next? Write down the shortest distance that you will need to reach those vertices. For example, when I try to look at B, so I'll need to start from A, right? So what is the shortest distance that I can reach B from A? So you can see there are different routes that you want to take. For example, you want to go around and after that go back to B also can. But you can imagine that's definitely not to give you the smallest distance that you want to take. Am I right? So that's why you will need to find out the nearest. So that's why the other alternative is pass through all this or pass through all this, but that's going to definitely more than 10. So that's why the shortest distance that I can reach B from A is 10. Okay? So when I am writing down 10, then maybe I'll try to use, if you have a highlight pen, right, then you can try to just highlight this number. But for me, I'm just going to put a tick, okay, by using different colors. So later when you understand how the whole thing works, then maybe you can use the same color to do that. So I'm just going to show you the whole picture so that you can understand how is this thing work. Okay, so now after finish B, then I'll be looking at D. Okay, so same thing. The questions that I'll ask myself is, what is the shortest distance that I will need to reach D from A? So you can see that maybe it can be 15 or it can be from A, C, and D. So you can see this is 15, this is 17 plus 12. So this is definitely going to be more than 15. If you go through here, it's going to give you a number that's more than 15 as well. So the smallest that I have is 15. Okay, so for 15, I'm using this number, right? So that's why I'm going to use the other color to just note down. I use 15 for this one. Okay, so now move on. So the next neighbor is C, right? So I'm going to do the same thing. So look at C. So what is the shortest distance that allow me to reach C from A? So you have 15, 12. That's going to give you 27, which is more than 17. So the shortest distance that you can take is 17. So that's why 17. Okay, then I'll use the other color here. Alright, so now after finishing this, then we are going to step 2. Okay, so remember that in the real question, you won't be given like so many diagrams. You are going to do everything in one diagram. But this is for your reference. When you try to repeat this in future, then you are able to look at what you are actually doing step by step. Okay, so the first thing that we need to do is let's try to copy whatever that we have in step 1 first. So we have 10, 15, and let me try to change to my color. Okay, so 10, 15, and 17, right? Then just now we tried to use the different color here, so let's try to note that as well. So we have yellow, and then orange, and then red. Okay, if you do not have any highlighter, then you just use your normal pen to make a tick is definitely fine. Okay, so now what is the next thing? Okay, so you see, ask yourself, what are the vertices that you have gone through in step 1? So just now you start from A, right? Then you have actually complete for B, D, C. So that's why the vertices that you have gone through in step 1 are B, D, C. Okay, so the next thing that you ask yourself is the same thing like what you ask yourself in step 1. what are the neighbors of all these vertices? What are the vertices that is adjacent to these vertices? So it will be E, G, and also F. So you wouldn't be able to reach H yet, right? Because you need to pass through other vertices, then only you can reach H. So in this case, then what I have here is E, G, and then F. Okay, then the next step is going to be the same thing as well. So what is the shortest distance that you can reach those vertices from your previous edges here? Okay, so now let's start with E. Okay, so you see, now you have two alternatives, am I right? So the first one is either you want to go from B to E, which is going to be 10 plus 11, or you want to go through from D to E, then that's going to be 15 plus 7. So you can see this will give you 21, this will give you 22. So which one is a smaller number? Then definitely it's going to be 21. So that's why in this case, then I will put 21 here. That's the shortest that I have. Okay, so since I'm using 11 here, then I'm going to use the same color, the yellow color here, to indicate that I'm trying to go through from A, B, and also D. Okay, I hope that you are still following my step. Okay, so now we move on to the next one. So we are looking at G now. Okay, so for G, same thing. Ask yourself, what is the shortest distance that you can reach G from your previous vertices here? Okay, so you realize that there's something special here is that when you try to look at G, right, you can go through from F to G, but you do not have anything in your F yet. So that's why you can try to think of, do you think that this will give you a smaller number or this will give you a smaller number? If let's say you think that this will give you a smaller number, then you will need to go through F first. But remember, all these number you can erase. Like what I said, if let's say you're trying to do G first, then after you find F, then you realize that this number plus this number actually give you a smaller number, then you can erase it. Okay, so that's the idea. This is just like a try and error kind of thing. Okay, so now by looking at this thing, then I know that 15, 19, that's going to give me 34. If I go through this, then this will give me 25. Maybe I'll have a smaller number. So that's why I'll choose to look at F first. Okay, so for F, you can imagine either you pass through here, or you pass through here, or you pass through here. So imagine which one will give you a smaller number. So it's definitely going to be 17 plus 8 here. So that's going to give us 25. So that's why it's 25 here. So imagine 21 plus 10 is already 31. So that's definitely more than this. I mean, you still need to pass through here, right? Here to here, then it's already 34. So it can't give you a smaller number if you want to go through here. So that's why this is definitely the smallest one that you can take. So in this case, I'm going to put a red color here because 17 plus 8. Okay, so after I do this, then I now go back to G. So same thing, by having this three number, then 1, 2, 3, 4. There are four number that you need to look at. Okay, so which one will give you the smallest one that you can take? So yeah, something to bear in mind for this one, you will have by having a good mental calculation can help you to do everything faster. So you wouldn't need to, press your calculator all the way, then you will actually lose a lot of time. Yeah. So use this time to practice on your mental calculation as well. So this path will give you 31, 34, and then 29, and also 31. So that's why the smallest one will be here. So which give you 29. So how do you get this? You actually passes through 17 plus 12, right? So that's why I'm going to put down the red color. Okay, so I hope that you're still all right. Okay, so now you can definitely know that for orange color, that's not going to be any use here lah, because you do not have any continuous thing here. Okay, so now same thing. Let's move on. So you already finished E, G, F, right? We are going to continue the last step by looking at the last adjacent vertex here. So before we do that, let's try to copy again. So we have 10, 15, and 17. Again, in your real question, you do not really need to copy because you will be given only one diagram. So why in the notes I want you to do this? Because if we are not doing this, then in future when you are doing your revision, right, by looking at this diagram, you doesn't know how do you get all this number. So that's why this is to help you to know that how do you get this step by step by using the first two example. Then after that, we'll move on to solve everything with only one diagram. Okay, so I have here, and then the orange color, and then also the red color, 1, 2, and also 3. I think that's it. Okay, Alright, so now let's continue. So what are the vertices that you have gone through in step 2? So just now what we have done is for E, G, and F, right? So E, G, and F. So same thing now, what are the vertices that are adjacent to this one? You're only left with one, which is H. Okay, so now by looking at this three number, then which are the which path that you will need to take so that it gives you a shortest one to reach H. So 21, 19, it gives you 40, 29, 12, so 41, 25, 17, so 42. So the smallest one will be 21 plus 19, which is going to give you 40. Oh yeah, if let's say you find it very difficult, right, what you can try to do is you try to write down lah. So 40, 41, and then 42. Then you just pick the smallest one, then you write down. So for everything, then you do the same thing lah. So that's the alternative that you can do. So for example, here you get 21, then here you get 22. But then in the diagram, you will have quite a lot of number lah. So if let's say you think that's going to be helpful, then you can do that as well. Okay, it doesn't matter. Okay, so now you see what I try to go through here is I go through 21 and then 19 to give me 40, right? So that's why I'm going to put yellow color. Okay, so which means that for me to get the shortest distance here, I passes through the yellow color edges. So this is to help me to do the calculation later. So later I won't be confusing with what are the road that actually I passes through. Alright, so I hope that you understand the meaning of the color. But then if let's say you didn't use different color, then you can just check your arrow lah. Because by looking at this one, you have the arrow here, right? Then when you try to trace back, then you'll realize that there's no arrow here, then there's arrow here, then definitely you go through this edge. Then by looking at this one, then the previous edge is here, the previous arrow that you have is here. So that's why it's going to be A, B, E, and H lah. So that's the idea. Okay, so the shortest route that you have is by passing through A, B, E, and then H. Okay, the shortest distance here is 10 plus 11 and then plus 19, which is going to give you 40. Alright, so in this case, there's no question here, so we are not going to write down any unit, but for the next few questions, then you are going to write down everything properly. Okay, so A, B, E, H. Alright, so that's pretty much for example 1. Then we are going to repeat the detailed steps again in example 2 for your better understanding. Okay, so now let's try to look at example 2. Alright, example 2, the network shown below shows the time in minutes. Okay, so which means all the weight here represent the quantity of time. Alright, and the unit is in minute. So that shows the time taken to travel along various sections of the routes. So according to the time, what is the quickest time that the journey from A to I can be completed in, and what route would achieve this quickest journey? Okay, so in this case then, which means your departure is here and then this is where you end. Alright, so yeah, similarly we are going to use the algorithm to help us to solve, because by you looking at this, then you know that inspection or listing all the possible route, it will be kind of like time consuming. Alright, so we'll start with that. Okay, so to find the shortest path which give you the shortest time needed to travel from the vertex A and F, you will start to look at the vertex of A. Okay, so which are the first few vertex that is adjacent to A, right? So this is what we have done in our example 1. Okay, so now what are the vertices that is adjacent to A? So you can see there's B, D, and also C. So in this case, same thing, B, D, and C. So write down the shortest road that you can take, the shortest path that you can take so that you can reach all these vertices. Okay, so now same thing, let's try to check it out. So you can see that this is 27, then definitely this is 53. So you are not going to go through here to reach B, right? So that's why the shortest that you have is 27. Okay, so I'm just going to show you one color, then at the end you will realize that it's just the same thing. So 27, this is where you take. Okay, so now when you try to look at D, so you realize that there's two ways that maybe you can take A to D or also A, B, D. So in this case, because this is 27 and this is 20, so when you add them up together, you only get 47, which is lesser than 53. So that's why instead of going through here, you were going through A, B, and D. So that's why remember what I said. So the shortest route doesn't mean that it's the shortest length of walk. So you will need to check out the weight rather than how many edges, how many vertices that you need to pass through. So in this case is 47 here. Okay, so the one that the ages that you take for you to reach 47 is 20, so you are just going to put a tick here. Okay, so now let's move on to the next one, so which is C. So for this one, then I think it's quite obvious. It wouldn't be like going here, right? So that's why it will be 35, because here it's already 47, which is more than this already. So it's 35 here, and this is the road that you take. Okay, so now you settle for your first round of your algorithm. So now let's go to the second round. So same thing, let's try to copy down the information. So 27, 47, and also 35. Okay, so just try to put a tick here. Okay, so next round. So you already gone through the vertices of B, D, and also C. So now what are the next vertices that are adjacent to these three? So it's going to be F, E, and also G. Am I right? So that's why F, E, and G. So you'll be looking at the shortest one so that you can reach all these vertices here. Okay, so you might want to start with maybe for 27 here, because when you try to add them up, then you can get 80. Obviously, you can try to check this out as well, because this one plus this one you already give you 73, which plus this one is definitely more than 80. If you want to pass through here, then yeah, maybe you can try that out. Yes, this is possible. Okay, so in this case, then you might want to find out for E first. Okay, so 47 plus 19, 35 plus 38. So this case you will get 66, and this one you will get 43. Sorry, 73. So which one is the smallest one that you can get? Then is definitely here. So this one will give you 66. Okay, so you passes through the 19 here. So that's why you see that if let's say this is the shortest path later, right, then the one that you backtrace, then it will be this one, and this one. So you can try to just check out the one that you take. Okay, so since you have 66 here, then you might want to look at this one. Okay, so just now we said that 27 plus 53, it gives you 80. And then 66 plus 11, it only gives you 77. So that's why in this case it's 77. So you are taking this one rather than the 80 here. Okay, so I mean you can try to put down your draft, so just make sure that you are not confused with your own writing lah. Okay, so after you get this, then now we left with G. So 35 plus 40, 75. So 66 plus 15, that give you 81. So that's why the smallest one that you can have is 75 here. So we should go through 40. Okay, so settle for the second round for the algorithm. So now let's move on to the last round, because you can see that H and I, they are adjacent to your previous vertex already. So that's basically your last round. Okay, so same thing. Let's try to copy down the information. So just now we have 27, 47, and also 35. And then 77, 66, and also 75. Okay, so let's check through the tick that you take just now. So we take this one, this one, this one, and also this one. And then for the bottom part, we have 35 and 40. Okay, so the vertices that we have gone through in step 2 are F, E, and also G. So now what are the vertices that are adjacent to all this? So it's going to be H and I. So that's why that's what we want to check now. Okay, so for H and I, so try to check out where is the shortest path that you have. Okay, so 77 plus 5, then you can get 82. So 86, and then here is 95. Then definitely when you go through here, it's going to give you a larger number. So the shortest one that you can get is 82, which will pass through the 5 here. Okay, so now you're at the last part. So you see there's only two edges that I mean going out, or there's only two vertices that is adjacent to I, right? So it's either 82 plus 10 or 75 plus 30. So obviously that's going to be the 10 here, and that gives you 92. Okay, then now you have your shortest path. So when you try to write down the shortest route, then you just backtrace it. So for example, in this case, the last one you have I, right? Then you are just going to write, backward. So your destination is I. So you just check your tick that you have previously is 10. So that's why you are passing through H. So before I, then you have H. Then before H, the previous tick is here. So that's why it's F. So where is the previous one? So you can see there's no tick here, then which means you pass through here. Then for this one, you have E. Okay, then you backtrace again, then you have D. Backtrace again, you have B, and then A. So you just track through 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, 6, which is correct. Okay, so now try to add, find out the total of the time that you need. So that's 27 plus 20 plus 19. So remember, you only take the one that you take it for your answer. So these two, you don't add them out. You get what I mean, right? So plus 11 plus 5 plus 10. Okay, so at the end you will be able to get 1 2 47 47 66 77. Oh, sorry, why do I need to count it around again? Okay, so it's 92 here. Okay, so this is 92 minutes, so that will be your last answer. So remember, this is the route that you need to take. So this is the shortest route. Then the quickest time that you can have is 92 minutes to reach I from A. Okay, so that's basically for example 2. So now we'll be looking at two more examples, but we are going to do everything in one single diagram because I hope that you already know how this algorithm work. Then we are just going to look at and then do it like normally how we do it. Okay, so now example 3. Okay, example 3, the weighted graph shows the taxi fare to travel from each town to another. What is the path that Alex should take so he can minimize his expenses in traveling from town A to town Z? Okay, so when you're trying to look at this, then this is where you depart, then this is where you end. All right, okay, so I just want you to make something clearer here is that this is different than what you learned previously, like the Eulerian and the Hamiltonian. I hope that you can see the difference of the application of all this concept. So when we talk about the shortest road, right, which means that you doesn't need to pass through every edge or you doesn't need to pass through all the vertices. Because what is our objective here is so that Alex can reach Z from A. So which town you actually passes through, it doesn't matter as long as I can find out the route that give me the minimum expenses. So you must understand what the question want, then you only can understand what do you need to apply. All right, so I hope that clarify. Okay, so in this question, sorry, I will try to add in the unit in your set. I think I left that out. So this is the taxi fare. Maybe we try to do in dollar lah. Okay, that's easier. Okay, so now let's try to find it out. So that's our unit here. So we are going to do everything in one single diagram here. So you understand how this thing, sorry for that. Okay, how this thing look like when you try to do it in one single diagram. Okay, so same thing. We need to start from A and then reach Z. So that's why by looking at A, what are the neighbors? What are the vertices that are adjacent to A? That it will be B, D, and then C. So we need to find out what is the shortest road to reach every single of them. So from this one, you can see this is the smallest number that you have. So obviously this is going to be 10. Okay, then when you move on to this, so 15, then 23, and then 29. So the smallest one is 15. All right, so you use this. So 15 or 12, then you get 27. Then this one 17 is even lesser. So you are going to take this. Okay, so now second round. So by looking at B, D, and C, which are the vertices that is adjacent to this tree, then it's going to be E, H, G, and F. So you start with the nearest one maybe. So you can try out for E first because you only have, you doesn't want to go through here. So definitely that's going to be BE or also DE only. So 10 plus 12 or 15 plus 10. So 22 is the shortest that you can get. So that's why you go through here. Okay, so now let's try to check the other one. So maybe you can try to solve for F first because you do not have other alternative, right? You can check if you want to go through here, then, this one you plus 20, then it's definitely going to give you a longer distance. To give you, more expenses. So in this case, then we will go through from 17 to 15. That's the only alternative here, then which means you passes through this, then what are you getting is 32. Okay, then the next one we have G or F. So depends on you which one you want to do. So like what I say, you can always check one, then after that you erase after you find if let's say you have something that is lesser than that. So don't worry about making mistake because you can always erase it. Okay, so in this case, then you can try to maybe you try to look at G first. So we try to assume that this thing wouldn't give you a shortest one, so we only try to look at 1, 2, 3. Okay, so 35 here and then 34 and then this is 41. So the shortest one will be 34 here. So that's why 34 and I passes through 17. Okay, 17, 17. Okay, so now we move on to H. Okay, so you have three choices here, either here, here, or here. So 39, and then 38, and then 42. So which one will give you a lesser number? So in this case, it's going to be the 38. Okay, so that's why 38 here. So of course, after you get this answer right, then you can always check back like 38 plus 8, is that give you a lesser number? If yes, then you are going to change this number and erase the tick here. So in this case, then you realize that, so no matter you are doing 34 plus 8 or 38 plus 8 is not going to give you a smaller number lesser than 34 and 38. So that's why this is the least value that you can find out here. Okay, so now you are looking at Z. So this one is easy lah. So only 1, 2, 3. So you just add them up together, 50, 46, or 48. So that's why in this case, it will be 46 that you passes through 12. Okay, so now same thing. Let's try to do backward scanning. So you start with your ending is Z. Then after that, when you trace back the tick here, then you have G. Okay, for the G, then the next one, you can see that for the H that you have, right, this is the only tick that you have, so that's why it should be C. Then by looking at C, back trace again, then that's give you A. Okay, so, oh, sorry, I'm writing C at the back. Yeah. Okay, so this is my C, and then this is A. So that's why my answer will be A, C, G, Z. Then when I try to find out the least expenses, so remember, just copy down everything again. So 17 plus 17, and then plus 12. Okay, and that gives us $46. All right, it's good that you try to check again with the network that you have. All right, I hope that is quite simple. Okay, so now let's move on to the last example. Okay, last question. The diagram shows a network of roads linking the location H, A, B, C, D, E, F, and W shown as a circle here. So the number of each road gives the road distance in kilometers between the location. So this indicates the distance between, every location here. So a motorist wishes to travel from the home at H to his workplace at W by using the shortest road. So which is the road that the motorist should take and how long is the distance? Okay, so by looking at this same thing, so by thinking of it logically, then you need to know that if let's say this is your house, then you are going to travel to your workplace, then you doesn't really need to pass through all the edges or all the vertices, right? As long as it gives you the minimum distance and you can achieve what you want in this question. So that's why what you are going to apply here is the shortest route. Okay, so now let's try to do the algorithm again. So I hope that you are now quite familiar with it. So if you are comfortable with it, then you can always pause the video and try it yourself. Then after that, check your answer. Okay, so this is a place where we start off. So that's why by looking at each, so the adjacent one will be A, C, D, and also E. So let's write down the shortest one that we have. So 15, this is definitely the one. All right, so now for C, you have 15, 7, or 20. So this is the shortest one, which is 20. So in this case, then 18. So this is 29. So that's why 18 is the smallest, is the shortest one than 17. Okay, again, if you are doing this, then suddenly you realize you miss out something like maybe 70, this is only 1, then when you plus them, you get a number that's smaller, then you can always erase it. Okay, so now then the next one we have B and also F. Okay, so from 20, 15 plus 20 give you 35, and then 20 plus 8 that give you 28. So that's why 28 here, then I pass it through here. So now by looking at F, so 17 plus 24, that's 41, 33, and then 34. This case is 39, so that's why the smallest one that I have is 33. So after I write down this answer, right, then I'll always check. So is 33 plus 11 give me a smaller number than 21, 28? No. So is 28 plus 11 give me 33? No. So that's why all these numbers are safe. Okay, so I pass it through 15 here. So the last one, W, is very simply simple. So 28 plus 18 or 34, 33 plus 14. So this will give you a lesser number, which is 46, and this is 47. So that's why 56, 46 here. All right, so that's your answer. So same thing, let's try to trace back your destination at W. Then after that, your previous one is B. Then tracking back the arrow here, then you have C. and check back your previous tick, then from C, then it will be H, right? So it's H, C, B, W. So the shortest route that you can take is from your home, then go to C, go to B, and go to your workplace. So the distance that you take is 20 plus 8 plus 18, and that give you your last answer, which is 46 km. Okay, so yeah, that's pretty straightforward. So now then let's try to look at the second part of the question. So after traveling the shortest route for several times, the motorist realized that he wants to travel by the quickest road, that the route that you have above here is not the best because of the speed limits and also the road condition. So he tried to estimate the time for him to take for each section of the route, that this is shown in the diagram. Because you can imagine, if let's say, I mean, for the shortest road, right? If let's say this is all the small roads and the road condition is actually not a good one, or they have a certain speed limit here, then even though the road is the shortest one, but it doesn't mean that you can reach the company like the fastest time in the fastest times that you can. So that's why in this case, what the motorist trying to do here is he tried to estimate the time for each of the section. Then instead of looking of the distance, he's looking at the road that give him the shortest time to reach the workplace from the home. Okay, so now same thing, we need to do the shortest road again. Alright, so start from age. So now you need to check it again. So yeah, I guess it's the same, 15 here. So 25, 28, so that's why 25. And then this one is 12. So 12 plus 10, 22, then 15. Obviously, this is shortest. Okay, so now the next one, B and F. So same thing, I'll try to check from B first maybe. So 15, 15, 30, 25, 11, that's 36. So that's why 30 is smaller. So I'll try to go through here. Okay, so after I got this, then I'll try to check here. 15, so that's 35, 37, 45, and then 40. So the shortest one that I can take is 40 here. Okay, then you realize, is that something wrong? So 35, do I try to miss out something? Oh yeah, this is 40, this is 35. So this is shortest. 35, 37, 45, and 40. So the shortest is here, 35. Okay, so again, after you get 35, please check when you try to add 10, is that giving you a smaller number than 30? If yes, then you will need to change this number. If no, then this is okay. Okay, so now we move on. So the last one, 22, 15. So this is 50, this is 52. So that's why 50. So your answer is here. So that's why you see that the route that you can try to take here, right, is different with the one that is above. So in this case, it's W. And then the next one, backtrace it, then you have F, then you have E, and you have H. So for this one, from the home, then you go to E, go to F, and then go to W. So when I try to add up the time, then I have from H to E 15 minutes, then after that E to F 20 minutes, then F to W also 15 minutes. Okay, so in this case, oh sorry, I'll try to add that in your handout as well. I forgot to write down the unit. So we'll try to treat it as minutes also, so 15 minutes. Alright, so that's pretty much the idea of it. So yeah, I hope that you can understand it. Then spend some time to go through your exercise so that you are familiar with the algorithm. Then also I do not talk about the special cases here because I want you to spend some time to think about that as well. So you'll realize that maybe for the last few questions in your exercise, it might be getting challenging and more challenging. So make sure that you spend some time to think of it. So basically everything is like very logical. You just try to spend some time to think of it. Then hopefully you can try to get the answer. Okay, so I'll see you again after your semester break. So yeah, so thank you.